Welcome everyone. Thank you so much for being here and being patient while we were trying to figure things out here. Thank you for joining us. So today we are going to talk about how you can simplify generative AI application development with AI agents on Mosaic AI. My name is Akriti. I'm an engineer on the Mosaic AI team, and I'm joined here today by my colleague Bilal, who will kickstart the presentation, and then I'll jump in with an exciting demo at the end. All right.
Thanks, Akriti. My name is Bilal. I'm a product manager on AI Inference. So here's the agendas for today's talk. We'll start by talking about what agents are, what benefits they give, what they are made up of. Then we'll look at some of the challenges with deploying agents. We'll then see few Databricks features that have launched this week that makes it easy to deploy agents. We'll then show you a demo where we will show how you can author and deploy these agents on Databricks, and then we'll end with a sneak preview of future developments in this area. So we're very excited about this topic. Hope you are too. Let's get started. Right, first thing first, what are agents? So today most of us use language models in a non-agentic workflow. You send a prompt, you get a response. So for example, imagine you want LLM to plan your vacation. And so what the model will do is that it will write the itinerary from start to end in one go. And in contrast, agentic workflows are very different. If you ask an agent to plan your vacation, the agent would probably first start with the outline. It will then go to the web, do some research. At that point, it might come up with a draft. It would review the draft. It might recognize, there are some gaps. Let me go and fix those gaps. It might ask for your user preference, or maybe you might be able to fetch user preference from memory. And so it continues, this process of iteration and revision. So agentic workflows are iterative with a lot more thinking and refinement happening. Before I dive too much into agents, let me show you a very simple 101 agent demo. All right, I'll switch to Playground. Playground is a tool within Databricks that you can use to easily access any foundation models, be it external models like GPT 3.5 or 4, or open models like Llama 3 or your fine-tuned models. You simply can pick a model from the drop-down and can start chatting with it. One of the things I really like, good call out. So one of the things I really like about Playground is that you can compare different models side by side. So let's actually go ahead and compare Llama 3 with GPT-4. All right, I have Llama here, and on my right-hand side, I will have GPT-4. Well, let's do one thing. Let's basically give agentic power to Llama 3. And I can do that by going to Tools here and giving this model access to a tool. So let me give this model access to get weather function. All right. So now let's ask a very simple question. What's SF weather today? All right, okay, one thing that you see off the bat is that GPT-4 refused to answer this question because obviously it does not have access to the live weather information. Now, if I switch back to Llama 3, I see something is happening here. Let's give it some time here. All right, okay, I see. All right, okay, here we go. We have the response. And it's saying that current temperature in SF is 15.4 with the wind speed of 23.2 and the direction of 251 degree. And so I'd have debugging enabled on it, so you can actually see like what happened under the hood. So everything above it is actually kind of like internal logs. And when I sent the query, the model received the query, it realized that the user is asking to get the weather in SF. But it really does not natively have that information. But it also realized that it has access to a certain tool that it can invoke to get that information. So it invoked that tool. The tool gave the weather information, the live weather information back to the LLM. Then the LLM was able to generate a response in a natural language. Now I can go and ask maybe a slightly different question. I can say give me a summary of next 7 days of SF weather. All right, let's see what's happening. Okay, now it pulled the information for the next 7 days of weather. And I'm assuming, all right, okay, that's not a response I was expecting. I was expecting a little bit neater summary. But yeah, I mean, it worked. It was able to give me like a summary of the next 7 days weather. And I can go ahead and ask like a little bit more complicated question. And so this one is saying like, I'm planning a vacation next week and considering Colorado, New York, and Montana. Which one will have the best weather? All right, let's see what happens now. And this is more complicated because I've given like 3 locations, and you might not be able to follow like what's happening here, but the model invoked the weather tool 3 different times. And then it came up with like a very sweet recommendation that Colorado will have the best weather next week. So that's like agents 101. And you all might look at it. Actually, let me go back to this slideshow. You all might look at it and say like, Bilal, that's cool, but why should we care about it? Like there are 2 big reasons: quality and simplification. Agents can drastically improve quality of your GenAI app. There have been a lot of research around it. Andrew and his team did research comparing agentic models with non-agentic models on code generation benchmark. And what they observed is that GPT 3.5 zero-shot got a score of 35%. GPT-4 zero-shot was way better than GPT 3.5 zero-shot and got a score of 65%. Now here's the thing, like GPT 3.5 with agentic capability was able to even beat GPT-4 and got a very impressive score of 90%. And if you take that agentic workflow and wrap it around like GPT-4, you can get like a score closer to 95%. I think it's very impressive. And it's not only research. We have seen a lot of practical use cases, including internal ones, where we are seeing that agentic workflows can drastically improve quality. The other big benefits of using agents is that you can use them to easily access your enterprise data sources. And in the demo, I showed you that you can use LLMs to talk to weather APIs. That's neat, but really the real value comes from when your agents can talk to your data sources and systems. And now you all might be saying, we can use chains. Absolutely. I mean, chains are another great design paradigm that you can use to retrieve information, let's say, from your vector search. And chains have their own benefits, like they're simple, they are deterministic, easy to debug, but agents are way more powerful and flexible. And let me demonstrate that with you an example. Let's say you're building a chatbot on top of your SQL data warehouse. So a chain implementation would look something like this. A chain will receive a query, convert it into SQL, execute it, and then the LLM will generate the final response. This seems very simple, but there are a lot of things that can go wrong with this implementation. What if the LLM hallucinates on the table name? What if the query that LLM generates is incorrect? What if you have a use case where you need to do these complex joins or run multiple subqueries. These are some of the things that are very, very hard to do with chains. But agents inherently are iterative. They can automatically recover from errors, and they can execute this multi-hop prompts and orchestration much more efficiently. So how are they able to do that? At the core, there is an agent reasoning loop. This loop is powered by language model, and the loop determines the next sequence of steps. So when you send a query to an agent, the agent takes that query and interprets what tool it needs to run and what should be the input parameter to that tool. That step, by the way, is called function calling or tool use. Now, tools itself are functions or apps that perform a certain operation. Like retrieving data from vector search is a tool. Running a SQL query is a tool. Performing some action, maybe creating a support ticket, is a tool. Right, so then coming back to our reasoning loop, the agent will then execute the specified tool to perform the necessary action. Once the task is complete, the agent will observe the output and will feed that information back to the reasoning loop. And this process continues, this process of taking action and observing the output of the action until the language model determines that the task is complete. Right, so despite all the promises of agents, deployment to production has been slow. And there are a couple of challenges that has contributed to this lag. Let's look at some of those. Right, so agents are non-deterministic, and that actually introduces issues with inconsistency in quality. And this could happen because of multiple reasons. The agent might pick the wrong tool, it might send the wrong inputs to the tool, or it might even pick the tool when it should not be even be picking the tool. And debugging agentic workflows is also a little bit hard because of the dynamic path the agents take. In addition to, let's say, all the metrics that you are monitoring for LLM and for RAG, you need to also monitor some agent-specific metrics, such as the trajectory of the path agents took, the efficiency of that path, and what were the intermediate values that were passed to the tools. Secondly, agents traverses multiple components and data sources, and that just makes it very hard to design and deploy. You need an agent or a reasoning loop. You need to deploy that on a CPU. That needs to talk to an LLM, and it needs to talk to your enterprise data sources. Practically, this means that you might need different serving platforms, one for the agent, other one for the LLM. Now you need to hook these two tools together, and this all gets very complicated because each use case might need a different LLM or might need a different source. Finally, governance is also very challenging with agents. Agents, because they talk to, again, multiple data sources and multiple endpoints, so your traditional governance concept that is restricted to data really doesn't scale to an agentic workflow. Right, next, I want to talk about 3 key capabilities that we have launched this week that makes it easy to author and deploy agents on Databricks. Firstly, we have function calling that improves the quality of agents. Secondly, we are making it simple to deploy agents on Databricks through Agent Framework. And thirdly, we are extending the concept of governance to also include tools. Let's look at each of these in a little bit more detail. Right, first, we are very, very excited to announce that you can now use function calling on Databricks on open source models. And you can perform function calling using the same API that you use for OpenAI. Function calling, like I said, is a very important and critical part of agent workflow. and can significantly improve the quality of agent. This does creates a question like, how do you even know like you are actually improving the quality, or how is agent actually improving the quality of your application? And for that, we have actually built agent evaluation tool. Agent evaluation tool can automatically evaluate agents through both automated and manual means. And as part of this tool, we're also introducing tracing APIs that can evaluate, that you can use for debugging agents and look into what are the intermediate steps that was passed to each of the tools. Right, next you can take that agent and deploy it on model serving. So unlike other providers, you can use Databricks model serving to deploy any AI assets, be it agents, chains, foundation models, and external models. And we are introducing two capabilities here that even simplifies the process for agents. One, we have Agent Framework, which provides some high-level APIs that makes it very simple to deploy agents, and also introduces two new capabilities, such as streaming and tracing. Also, we are making it very simple for you to be able to talk from serving endpoints to your data sources by automating all the credentialing and providing enterprise networking capability, include private link. Right, finally, governance is a very core part of Databricks, and we are extending this concept of governance to also include tools and endpoints. The tools can now be managed in a similar way you manage your data and models. And then you can manage all your endpoints through AI Gateway in a very consistent manner. We're also introducing a couple of things in AI Gateway, such as guardrails, usage tracking, and payload logging. So enough talking. I want to bring back Akriti so that she can show you all the things that I talked about in action.
Thanks, Bilal. So before I get started, I wanted to ask, like, how many of you use Databricks today to build your generative AI application? Oh, wow, that's a good number. Okay, so, all right. For the purpose of this demo, let me pretend that I run a large travel company. And in that, like, I'm building a travel bot that basically helps my customers with reliable information about travel questions. And on top of that, let's say that in order to do so, like I have built this bot on top of my enterprise data in Databricks, so that my travel bot not only has general intelligence, but it also has data intelligence that's coming from using Databricks here. All right. So currently, like, I have deployed this bot internally for testing purposes before I deploy it out to production. And for that, like, I am using Agent Framework, which has created a framework which has created this review app where I can pretend to be a user, like send some request responses, and also provide feedback to the bot. So let me try sending some questions here. I'll start a new chat. And like, I really don't know where I want to travel, so I'm going to ask the bot like some recommendation for my preferences. So, all right, I had crafted something here.
Zoom in.
All right. So I'm looking to go on vacation on an island with warm and sunny weather, and I'm asking the bot to like give me some recommendations here. So what the bot is doing is like it's doing some planning and trying to match my preferences and give me a recommendation on the basis of that. So it has given me a list of places that I could go on vacation. Hawaii seems to be the first one. This is using general intelligence. Like, it's not using any tool in the backend, and it's just like basing it off of like what it knows are like good locations. Now, I know like Hawaii is really good. Like, let me try to find like some hotels in Maui, because I know that accommodation can get very expensive. So I'll ask it like, find me some good hotels in Maui. All right. So now for this type of information, I do not want the agent to like give the response on top of like general intelligence. I want it to use my data intelligence so it can give me right result without hallucinating. And for that, like you can see here that it has given me a list of hotels that are actually based on for tool that I created. I'm also running this in debug mode, so you can see like what tools were invoked. Here, for example, it called this search location tool. So we'll go into that and see like what it is. As Bilal mentioned, like all these tools are basically functions that I have written in the Unity catalog. And most importantly, like what's important for a tool is like it needs to be able to tell the agent its schema, as in like when should that tool be invoked and what are the input constraints that the agent needs to know when invoking that tool. So here you can see that this tool should be invoked whenever like a user has a search type of a query, and it tells that maybe we should invoke this tool with search query and category as an input. All right, so going back, this was the first question that I had, but you know, like this list doesn't capture my personal interest. And my interest was to get maybe like a hotel that was next to a beach that had a fitness center and has good reviews, maybe like with friendly staff, because that can of course like change all of our experience staying in a hotel. So I asked the agent that, and I asked it to plug it down to just top 2 recommendations. I don't want like a huge list that I have to go through. So let me see. So here, like what the agent is doing is basically like it's working its way, it's getting the request, sending it to the agent endpoint. That agent endpoint right now is talking to a GPT-4 in the background that was doing some reasoning, calling the tools, and gave me this response, where it invoked 3 tools because this was a complex query that I asked. And here you can see that it recommended 2 hotels that met all my criteria, and it also gave me a bunch of additional information that I could use to make my decision. So 4 Seasons and Hyatt, and looks like 4 Seasons has like slightly better rating than Hyatt. So maybe let me ask like my another question, which is, you know, like I am very flexible, like traveling in the next 6 months, but I do not want to pick a hotel that is going to not be friendly to my pocket. So let me ask it like, what will be the best time to travel in the next 6 months based on the price, like at, let's say, 4 Seasons. And at this time, like the agent is again like going to do the reasoning of like, it knows my criteria is price. And based on that, like it's trying to find like maybe what is the best time to travel based on that. So, all right, waiting for the response here. So looks like it did couple of things. Based on the forecasted price over the next 6 months, it gave me a breakdown of the price over the various periods. And it told me that the lowest forecasted price is actually March, making it like the most cost-effective time to travel to 4 Seasons. So it did that through like 2 tools, which I want to show. The first one is my enterprise data, and it's actually a very simple SQL query that is getting like maybe the current price from the hotel's table. Now this query is being made over my catalog. So maybe let's go see the catalog here, where you can see like all the tables that are there. Like these could be structured or unstructured data. For example, I have like my hotel prices, which was like structured data, but I also have my reviews index, which is the unstructured vector search data, which I could like do unstructured queries over. And then it basically called another forecast price model, which is my traditional ML model. This is a traditional ML model, which is also in Databricks. And all it's doing is like basically taking the hotel name, the current price, and sending it over. And the forecast model is doing its magic in the back and giving me like what is the forecasted price over the next few months. All right, so this is pretty cool. Like, this is a very complex compound AI system that required many different components. And let's take a look at like what all components I needed to make this travel bot. All right, so as you know, like first I needed to identify like different data sources that can enhance the knowledge base of the AI agent that can help me plan. We saw that I needed a search API that can give me some general information. Then I needed to talk to my enterprise data sources for the current price, for hotel reviews, and aggregated information. And then finally, like I needed a forecasting system that helps my user plan for the future information. And all these various systems are individually complex and hard to manage. So I was using Unity Catalog to find and search all these sources as well as like to create some of them. So we saw all the data, but like you must be asking like why, how, and why like I can create a tool. So let's see how I can do that. To do that, like I'm simply defining a function here in my ML agents catalog, and the function takes a simple parameter. I'm defining the schema so that the LLM knows when to invoke this tool and what input parameters to provide, and that's it. So let's execute that. All right, the tool has been created. And then I can do a simple select query over that tool to test out that the tool is working correctly. So it looks like it does. And all right, so with this, like what we see is that I can define a simple function in UC. It can be a Python function or a SQL function, and that can do some data fetching or some execution on my behalf. And I'm using like the same catalog that I was using for my data. So I can manage the tools in the same way that I was managing like my data with. So, all right, so now like we have all these things, like we have data, we have tools. Maybe let's try to combine it all together to create an agent. And for that, let me go here. So this is where like I'm pulling all of the tools that I had defined in my ML travel catalog, and I'm providing a SQL warehouse for it to fetch that information. So this UC function toolkit integration with the LangChain provides me with a simple API that I can use to integrate any function in UC and provide it to the LangChain agentic application. So what do I see here is basically like all the tools that were accessed, as well as like the schema that was part of the UC function that I had created earlier. So once that is done, like once I have all my tools, what I can do is I can define an agent. What I want to show here is basically it's very easy to experiment with the agentic application. So here, as I mentioned, like I was earlier using GPT-4, but I've been hearing rave reviews about like Llama 3, which is open source. So maybe I'll try creating my agent with Llama 3 here. And all of this is like behind the same AI gateway. So I can easily swap different models as I did right now. And I can try to run the agent locally to test it out. So here, like I have the agent and my query, which is to find flights from SF to Maui. And then I just run this particular query. So we can see that agent is going into its chain of thought, and it's doing a couple of queries to different tools, and it has generated a final response with the with the flights that were available. And here you can also see that basically this gives me a simple tracing of what exactly happened. So first, it called the chat OpenAI application, so API, to call the Llama 3 model. The Llama 3 model basically like generated an output that said that it needed to do a tool call to fetch that information. Then it actually did function calling to invoke that particular function, which returned like some data. And finally, like the agent decided that it had everything and it didn't need to, like, it called out that this query can be returned to the user. So this is how like I create agents locally within my notebook and test them. And now that like I have reasonable confidence that this is working okay, I will push it to staging by deploying it so that I can give it to my different business users who can try it out, test it out, give feedback of how the agent is working out. For that, let me share another notebook. So here, I am registering this agent into Unity Catalog again as a model so that this can be governed in the same way that I was governing my tools and data. And then I had already like created one version yesterday, and then I'll like deploy this using Agents Framework. Agents Framework is what Bilal talked about. We launched this week, and with that, like it makes it really simple for me to deploy any model to Databricks. So I'm passing the agent that I had just created. And what I'm doing here is I'm providing it resources that the agent needs access to. As we saw, the agent was complex and it needed different data sources. For that, like I'm passing it a serving endpoint, which was the forecast price model, and then a vector search endpoint, which was the index, and it would automatically do connections and credentialing for all these resources that my agent needs. Finally, like once it executes, like this step usually takes long time, so I'm not running it here. We get a endpoint which hosts the agent, and we get a review app, which I had showed you earlier in the demo. So let's take a look at like what is part of that particular endpoint. All right, so you can see here, like this is really meant for like testing and A/B testing as well. So you could like, I deployed a couple of versions. Right now I'm using version 5 because I didn't want to mess up my demo here. But I could test like multiple versions with like different models and everything. And I could try them out by sending the traffic to them here. I can also get some basic monitoring. So I get the latency request of the APIs that I've been sending. As well as if I go back, we can see that this AI gateway is basically a unified AI gateway for like all types of models. So my forecast model is also here, my agent is here, and as well as like a couple of foundational models that are provided by Databricks that I could use for running my application. All right, so let's go back to the agent. One other thing that I want to show is like by default using the agent framework, I'm getting payload logging enabled for this agent. So what that does for me is it provides me with all the request responses that were sent to that agent. So I can debug the quality of this application. So here, like you can see that it has request, response, latency, which is like the execution time here. And it also has request logs, which contains like detailed tracing information. So when I have that, like I can basically build a dashboard over it. Like all of this data is part of Unity Catalog, and I can build a dashboard over it. So I've created this dashboard, which maybe tells me that maybe like my execution latency is a little bit high, which I need to look into. So with this, like basically like the end-to-end flow of like how you would be developing an AI application and debugging it using like the payload log or the traces. All of it is made possible through this agent framework SDK. So let me go back to recap. Like we saw a lot of things. Maybe I forgot like what all we saw. So here, like we basically saw how Unity Catalog provided me with a unified way to access like all the data sources and tools. It also provided me with easy way to like share them across. We saw how Unified AI Gateway provided us with the ability to manage credentials and unified API and monitoring. And then finally, like we got built-in tracing and payload logging for quality assurance purposes. All right, handing it back to Bilal.
I know a little bit late, so yeah, I mean, thanks, Akriti. So, I mean, you can use LangChain, Llama Index, use the new Databricks capabilities, and build an agent. And we are very excited about all the announcements that we did this week. But we want to even make it simple, because if you look at the existing workflow, this is what you have to do. You have to author the tools, then you have to write your agent code. Llama, you can use Llama Index, you can use LangChain. Then you have to connect that code to your LLMs. Then you need to test the code. You need to make sure like your end-to-end quality meets a certain bar. Then you need to deploy it. And if something goes wrong in the deployment process, then you need to also maintain that deployment. And so we have been thinking like really how we can even simplify it more. And so internally we have been working on what we right now are just calling hosted agent capabilities. And the workflow for hosted agent capabilities looks something like this. You author your tools, and that's it. You can just pass your tools to the LLM. No need to deploy your agent. No need to do anything like that. We'll make sure like we'll handle all the infrastructure for you. And you saw like a glimpse of it at the start of the demo. Let me show you few more details around it. So I'm going to switch back here to the playground. All right, let's clear the history. And so the first thing that you have to do, write your tool, put it in the UC, and then you can just pass that tool to the LLM through an API, and you can also do that in the playground. So for example, I'll go here, and let me give this model access to like a general web search tool. So ml.tools.search_web. All right, and let me now ask a question here. What did Fed decide on the lending rate? All right, let's see. Okay, so it immediately recognized that it needs to invoke the tool, and it did. Ooh, should have worked by now. It's a live demo, and it's also on dog food, so. Okay, all right, so the response is the Fed decided to keep the benchmark lending rate the same, and they made this announcement June 12th, so it's very, very recent. It was just made like two days back. And so, you saw it's very, very simple. No LangChain, no Llama Index. You can like just by creating a tool and giving it to this agent, you have like a very flexible agentic workflow. Now, obviously, like this was using a general purpose like search tool. You can also give this access to your tools that sits on top of your databases. So for example, I can just do ml.travel.search location. So this is like a tool that access my internal databases. And I can just say like, hotels in Seattle. Right, I probably messed up with the name of the tool here. Is that the name of the tool? Is it just location?
Yeah.
All right.
Oh, travel, ml.travel.
Yeah, sorry about that. Working on improving the search capability here. All right. All right, okay. And now, it's actually making a call to my internal database to get that information, and it gave me like a list of some hotels in Seattle. So in addition to your custom tools, we are also exploring built-in tools. So with built-in tools, you don't even have to write the tool. You can just enable them and start using your agent. So one of the tools that we are exploring is called code execution. And you can basically enable it like this. And then you can use it to perform maths or to even make direct calls to your SQL data warehouse. So let me say, what is very large number multiplied by very large number divided by also a large number. All right, now LLMs are actually notoriously bad with maths. But what happened here is that this agent ran that on a compute so that it gave an accurate and correct response. But like I said, you can also use this whole concept to query your SQL warehouse. So for example, I can say, how many rows are there in ml.travel.reviews? So the agent will write the SQL query, will execute the SQL query, and will give the response back. So this makes the whole deployment experience very, very simple, and we're very excited because this will really accelerate the path to production. Let's very, very quickly recap. So agents can drastically improve quality and simplify GenAI app development. We believe this will really open up new GenAI use cases and will accelerate the path to production. Secondly, you can start authoring and deploying agents on Databricks through some of the new capabilities that we have launched, such as function calling, agent framework, and tools catalog. Finally, we are working on a hosted agent capability. If you are interested, I encourage you to sign up for private preview. We will have a QR code that you can use to sign up for the preview. All right, thank you all for coming. Thank you for listening. We're excited for all the very cool applications that you will be building with agentic workflows. Thank you.